Welcome dear students, and here is how to rationalize the denominators including radicals. So the idea here is to make the denominators rational. From the word rationalize, that's related to rational, it means that I have to change the denominator from an irrational including radicals to a rational without radicals. Here is the first example. I need to rationalize the denominator of 1 over radical 7. So all what I have to do is to multiply by the same radical as you see here, up and down. So as if I'm multiplying just by 1, because radical 7 over 7 is 1. I'm not changing the value as well. I'm just changing the form of this number. So by multiplying radical 7 by 1, I will get radical 7, and radical 7 times radical 7 is 7. So if you calculate this radical 7 divided by 7 on the calculator and 1 divided by radical 7 on the calculator, you will definitely get the same value. All what's different is just the form. Now, what if I have in the denominator, for example, 3 radical 7? What should I do? What if I have 3 times radical 7? Also, I just multiply by the radical regardless of the 3 that's multiplied by the radical. So I multiply by radical 7 up and down, and then I will get radical 7 over 3 times 7, which is radical 7 over 21. Also, the denominator is irrational. Now let's move to this second example. 1 over radical 3 plus 2. I used to multiply the denominator I have by its conjugate. If you remember, radical 3 plus 2 has a conjugate of radical 3 minus 2. These numbers are the same. The difference is only in the sign between them. So if it is a plus, I multiply by the same numbers but having minus in between them, also up and down. Now 1 times radical 3 minus 2 is the same as radical 3 minus 2. Now multiplying radical 3 plus 2 into radical 3 minus 2, I usually use the method of the difference of two squares, the identity of the difference of two squares, which says I have to square the first one, which is going to be radical 3 squared, minus squaring the second one, which is going to be 2 squared, and thus I will get 3 minus 4, which is minus 1, as you see here. So to save my time, I don't have to expand one by one. I just use this rule, squaring of the first minus squaring of the second, and to get an integer here, which is minus 1. Then moving the minus sign upwards, I can get 2 minus radical 3 by reversing these numbers, the order of these numbers. Now let's move to the third example, which is radical 5 over radical 7 minus radical 2. Notice the sign in between them is minus. Then I'm going to multiply by the same numbers but having a plus sign. The opposite sign of this is plus. In the middle, up and down, as you see here. Now I start expanding. As you see, radical 5 times radical 7 is radical 35. Radical 5 times radical 2 is radical 10, and as I told you just before, radical 7 minus radical 2 into radical 7 plus radical 2, all what I have to do is squaring of the first minus squaring of the second, and I will get 7 minus 2, which is 5, and I keep it like this. Okay, so what do we call this value? I'm multiplying by up and down. Here it is radical 7 plus radical 2, and here it is radical 3 minus radical 2. We call it the conjugate. So the value I'm multiplying by, in order to make, here I multiplied by this radical 3 minus radical 2, and here I multiplied by radical 7 plus radical 2 in order to make the denominator a rational without radicals is called the conjugate. Let's continue to talk about more ideas. Here is a very important rule that says that radical of a minus b squared is going to be a minus b. If a is greater than b, I put it a minus b. I carry it out as a minus b if a is greater than b. So if the greater number is first, I keep it as it is, while if the greater number is the second one, for example, if a is less than b, then b is the greater, I put the greater minus the smaller, so I put it b minus a, because the results of radicals are always positive. That's why I should put the greater number minus the smaller number to get a positive value. Because here the greater is b, then I put b minus a in order to get a definitely positive value. And here are examples on this rule. For example, to simplify radical 3 minus 2 all of it squared, it's definitely 2 minus radical 3 because radical 3 is about 1.7. Because 1.7 is less than 2, then I have to put 2 first, and the answer is 2 minus radical 3 since 2 is greater than radical 3. Also, if I have 4 radical 3 minus 7, okay, it is 7 minus 4 radical 3, since also 7 is greater than 4 radical 3, because 7 squared is 49 and 4 radical 3 squared is 48 if I have to compare them, or I can use the calculator to see which one is greater. So the idea here is that to say that whenever I have two numbers subtracted together and raised to the power 2, then I have to pay attention when carrying them outside the radical. I have to put the bigger number, the larger number, minus the smaller number. Here is another rule that says that radical x squared is going to be x as it is if x is greater or equal to 0, i.e. positive. So if x is positive, I carry out radical x squared just x, while if x is negative, I carry it out as minus x. Let's explain this one. If x squared, if I have radical x squared while x is something negative, for example minus 3. So suppose that x is equal to minus 3. That's some negative value. Now if I carry it out as x, then as if I'm carrying it out as minus 3. And that's a contradiction, because in radicals I have to get a positive result always. So what should I do? I should put a minus sign before x, as if I'm putting a minus sign before this number, and putting this minus sign will change it into a positive. That's why if x is given a negative number and the condition is written that it's a negative number, then radical x squared is going to be carried out as minus x, and here is the proof here. Because if I carried it out x as it is, then it includes a minus sign, and that's impossible for radicals. That's a contradiction with the principle of radicals. So that's why I need to put a minus sign before it to get minus times minus plus. So as if here I'm putting minus besides a minus value, and thus it is going to be a positive value. And here are examples on this idea that's very, very important. Radical of minus 3 squared will be 3 only. So I carry it out as 3. This is because I have radical of minus 3 squared is going to be 3 squared because the power is even. Okay? Then the minus will be then we will get rid of the minus and the answer will be 3. Now here if I have variables a that is positive, greater than 0 means positive, and b that is negative, less than 0, and I have to simplify this expression. Radical 25a squared minus radical 49b squared. Now let's apply this rule. 25 is going to be 5. A squared, because it's positive, we keep it as it is. So we have 5a, while minus is kept here, minus is kept, as you see. Radical of 49 is 7, while b squared is going to be minus b. Why? Because b is negative, then to carry out radical b squared, I have to put it minus b. Applying this rule here, and thus the answer is 5a plus 7b. Let's continue the other example. I have radical a to the power 4, b to the power 6. So it is like a power 2, a power 2, b power 2, b power 2, b power 2. This is how to explain this one. Now I can split the radicals. Radical a squared times radical a squared times radical b squared times radical b squared times radical b squared. Each radical a squared is going to be a times a, and each radical of b squared is going to be minus b again, because b is negative, then I have to carry out radical b squared as minus b, because b is negative, so I have to put a minus sign before the negative that it has. Then finally I get minus times minus plus times minus is minus, we put it here, a squared and b cubed.